Hello friends, welcome to the another tutorial of basic electronics module. In this particular tutorial, you are going to learn about the DC motors. That this particular session will cover the different topics like what is DC motor, working principle of a DC motor, different types of DC motor, and the applications of DC motors. Means in this session we are going to cover the so many aspects of DC motors. So this particular chapter is divided into four different parts. In the first part, we will introduce you with the DC motors. In the second part, you will see the working principle of DC motor. And the third part, you will see the different types of DC motors, specifically the self excited and separately excited DC motors. And in the fourth type, you will see the brushless DC motors and brushed DC motors and their applications. So let's just introduce you with the DC motors. Let's start our first introduction part. So basically, these are the motors which are widely used and you can see them around you, like in the home appliances, for example, in mixture, in coffee makers. Also, you can see them in hair dryers and in small toys. This kind of DC motors are found. So, DC motors are nothing but a device which is capable of rotating the different components connected to it. So these are nothing but they are used to rotate the different parts. So a DC motor. So it has two different terms. First is DC and then it is a motor. Motor, which means a device which converts electrical energy into mechanical energy. So this is for motor. And the DC term. DC means direct current. This is a device which operates on direct current. So, a DC motor is any type of class of rotary electrical machine that converts direct current, electrical energy into mechanical energy. So, nearly all type of DC motors have some internal mechanism, either electromechanical or electronic, to periodically change the direction of current in part of the motor. So, what happens in DC motor is there are some dedicated parts which periodically changes the direction of current provided to the DC motor. Now, this is how the inner mechanism of a DC motor looks like. Not in each and every motor, but the basic inner mechanism is something like this. They have a permanent magnet, a rotor, armature, and the terminals to which you can provide a DC current. Now, these small motors are used in tools, toys, and home appliances. But the universal motor, a lightweight brushed motor used for portable power tools and appliances, can operate either on direct current or on electric current. So, there are some universal motors which are lightweight and brushed. They are able to operate on direct current and alternating current. The larger DC motors are currently used in propulsion of electric vehicles, elevators, and hoists, and in drives for steel rolling mills. So, these are the application areas of large DC motors. Now, the advent of power electronics has made replacement of DC motors with AC motors possible in many applications. So, now the AC motors are made in such a way that they have replaced the DC motors in some application areas. But in tools, toys, and home appliances, still DC motors are widely used because they have higher starting torque. And due to this advantage, they are used in tools, toys, appliances, and heavy load machines. Also, they have high variation or high variety of speed change, means they have a wide range of speed variations. Hence, they are used in so many applications nowadays. Now, first, let us see what is a DC motor. So, a DC motor is defined as a class of electrical motors that convert electric energy into mechanical energy. So, a motor stands for converting electrical energy into mechanical energy. From the above definition, we can conclude that any electric motor that is operated using direct current or DC is called as DC motor. So, any electric motor which operates on direct current is known as DC motor. Now, as you can see here, a small DC motor typically used in toys and dryers and mixers and coffee makers, they are mostly like this. So this is how your typical small DC motor looks like. So this is the practical module of DC motors, and this is the inside mechanism of DC motor. Now, powered by DC current, they moves mechanical parts. So DC motors are used for moving mechanical parts. So as the operation of it goes, that it is taking DC current, means in input the DC motor is taking a direct current, means it is an electrical quantity, means it has input in the form of electrical energy, and in return or in the inner mechanism, due to which it rotates a mechanical part. So this is called a motor, also a DC motor. Now, as you can see in this DC motor module, here there are two terminals. These are the two terminals which are used to provide a direct current to this DC motor. So, in either of the terminal, you can connect positive and in negative. Just this alternation will alter the rotation of your rotor. If you connect this positive and this negative, then uh, it will be rotate in a particular direction. And if you alter the connection, means if you connect this wire to this and the previous wire connected here, you will connect it here, then it will change its direction of rotation. So this is the two terminals provided to give DC motor and DC power. So, in input, the DC motor is taking direct current, which is electrical quantity, and due to this inner mechanism, it starts rotating this rotary part. So, by connecting a wheel or shaft or any part, you can move that wheel or shaft. So, the DC motors are there to move or to give a rotary motion to different parts. So, it converts electrical energy into mechanical energy. Now, you can see these are the examples where DC motors are used in a coffee machine, in solar rooftops, in a table fan, in the wipers of a car, in cranes, in the trains, in this wiping machine, in elevators or lifts, in drilling machine, and this kind of rolling machine. These are the day-to-day life examples of a DC motor. Now let's see the working principle of DC motor. Let's first see its constructional parts, that which are the parts are there in a DC motor. So in this middle area, there is a shaft which is turned or starts rotating whenever a field is connected or a supply is connected. Then there are pole shoe. This is a pole shoe. These are the armature conductors. This is a magnet. This outer part is field winding. This is interpole. These are the interpoles, and this is a commutator. After the shaft there is a commutator. After a commutator there are armature conductors. then interpoles, then pole shoe, then field windings, and the outermost part, which is enclosing the inner mechanism, is your yoke or frame, which is the outermost part. And these are nothing but legs. So let's just see its essential parts. First is armature, or you can call it as a rotor. The armature of a DC motor is a cylinder of magnetic laminations that are insulated from one another. The armature is perpendicular to axis, means the axis and the armature, they are perpendicular of the cylinder, means whatever the axis of cylinder and the axis of armature, they are perpendicular. The armature is perpendicular to the axis of cylinder. The armature is a rotating part that rotates on its axis and is separated from the field coil by an air gap. Means there is a air gap in between armature and field coil. They are separated by this air gap. And this armature is the rotating part of your DC motor that rotates on its axis. Means the armature rotates on its axis, and it is the rotary part of your DC motor, and it is separated from the field coil by an air gap. Now the second is field coil or stator. A DC motor field coil is a non-moving part on which winding is wound to produce a magnetic field. Now these field coils are responsible to produce a magnetic field, and these are the stationary or non-moving part. This electromagnet has a cylindrical cavity between its pole, means between their poles they have cylindrical cavity. So the armature is rotating part while your field coil is a stationary part, which is a stator. Now the third one is commutator. The commutator of a DC motor is a cylindrical structure that is made of copper segments stacked together but insulated from each other using mica. The primary function of a commutator is to supply electrical current to the armature winding. Means it is necessary to provide electric current to armature. Means armature is responsible to supply electric current to the armature winding. And fourth one is brush. The brushes of DC motor are made with graphite and carbon structure. Means the material used to make brushes is graphite and carbon structure. These brushes conduct electric current from the external circuit to the rotating commutator. Means these brushes first conduct the electric current from external circuit to the rotating commutator. Hence, the commutator and the brush unit are concerned with transmitting the power from the static electrical circuit to the mechanically rotating region or the rotor. Means this combined unit of commutator and brush, they are responsible for transmitting electric current from where? From the stationary coil to the mechanically rotating region. Means they provide a transmission of power from a stationary part to rotating part. So this was about the essential parts of DC motor. Now let's see how they work. So, first of all, as we have seen that DC motors are a rotary device which rotates. So, a DC motor is an electric machine which converts electrical energy into mechanical energy. The basic working principle of a DC motor is that whenever a current carrying conductor placed in the magnetic field, it experiences a mechanical force. So our DC motors are made the way that there is a permanent magnet and also a field coil. Now the DC motors, whenever the current carrying conductor is placed in a magnetic field, it 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 enables, or it experiences a mechanical force, and this mechanical force is nothing but it starts rotating its rotor. In return, it moves different parts connected to it. So when kept in a magnetic field, a current carrying conductor gains torque and develop a tendency to move. And the tendency to move is nothing but a rotation. So whenever you keep it in a magnetic field, what? A current carrying conductor. So there is a current carrying conductor, which is kind of an electromagnet. And in magnetic field means magnetic field is provided by magnets. So when there is a current carrying conductor in a magnetic field, it gains torque and it develops a tendency to move. So in short, when electric field and magnetic field interacts, a mechanical force arises. This is the principle on which the DC motor works. So this is the basic principle. A magnetic field arises in the air gap when the field coil of DC motor is energized. So whenever the field coil of DC motor is energized, a magnetic field arises in the air gap. The created magnetic field in the direction of the radius of the armature. Now, in which direction this magnetic field is produced? In the direction of the radius of the armature. So, the production of this magnetic field is in the direction of the radius of the armature. The magnetic field enters the armature from the north pole side of the field coil, means it enters from north pole side of coil and exits the armature from the field coil's south pole side, means entering side is north pole side of field coil, in exit side is field coil's south pole side. The conductors located on the other pole are subjected to a force of the same intensity but in the opposite direction. So, the endmost poles are subjected to the force in the opposite direction, means the force applying or for experiences on the poles at the end are of same magnitude but in the opposite direction. These two opposing forces create a torque that causes the motor armature to rotate. Means here two forces are produced and these two opposing forces create a torque due to which a motor armature starts rotation. So this was the working principle on which a DC motor works. This is how a production of torque takes place in a DC motor. These are the constructive parts of a brushed DC motor. This is a brushed DC motor because there are two brushes in this motor, hence it is named as a brushed DC motors. So these are the two stator magnets, means this is the stationary parts. This is one and this is another magnet. This is the armature. After it there is a windings. These are the different windings. This one is a commutator and as you can see there is there is a space in between this commutator, this and this. There is a separation. These are the two brushes and after that there are the two terminals. So this is the constructive parts and the representation of a DC motor. Now let's see the different types of DC motors, that in which categories DC motors can be divided. So in this section we will see the different types of DC motors and their applications. So the DC motors are differentiated in so many different types, and these DC motors can be classified according to the winding connection, according to the magnets used, if it has brush or no brush. So these are the categories onto which a DC motors can be classified. So one classification of DC motor is shown here. So this is the three types of a DC motor, which is a separately excited, a self excited, and a permanent magnet type DC motor. So in self excited DC motors, there are three different types. First one is shunt excited, second is series excited, and third one is compound excited. Now these compound excited DC motors are further divided into two types, and this two type has the similar two different types. One is cumulative compound and the another one is differential compound. Now this cumulative and differential compound motors are further classified in long shunt and short shunt. So these are the types of DC motors. Now let's first see the DC motors different types according to the winding connection. First one is separately excited DC motors. As the name suggests, it has a separate excitation in the field winding, means the field winding is separately excited. As you can see here, it has two different circuits, means the supply is given separately to the field and armature winding, means this is field winding and this is armature winding, and in this field winding the supply is given separately. The main distinguishing fact in this type of DC motor is that the armature current does not flow through the field windings. Means the armature current, whatever amount of current in the armature doesn't flow through the field windings. Means it is not going here. As the field winding is energized from a separate external source of DC current as shown in the figure. Why? Because the field winding is energized by a separate DC source. Hence, the armature current does not flow through this field winding. So, in separately excited DC motors, this type of structure is made. This is IF, means the current flowing through field winding. This is IA, which is the current through the armature. Here, the current IL means the current flowing through the load and voltage across it. Now it is RA and this is EB. Now RA stands for armature's resistance and EB is for back EMF. Now it is a back EMF, and this back EMF EB is nothing but, since the armature of a DC motor rotates in a magnetic field, an EMF is induced in the conductor of armature due to the electromechanical induction. Now, when the DC motor rotates in a magnetic field, there is an induction of EMF in the conductors of armature due to the electromagnetic induction. Now, this induced EMF acts in the opposite direction to the applied voltage. This induced EMF is in the opposite direction, or it acts in the opposite direction to the applied voltage, and hence it is known as back EMF or counter EMF. Hence it is known as back EMF, which is EB. Now, the second part or a second type is self-excited DC motors. Means these are the DC motors which are self-excited or have a single circuit. The self-excited DC motors has the main field winding. These motors are further divided into three types. The first is series wound DC motor. E is shunt wound DC motor and C is compound wound DC motors. So let's first see the A type, which is series wound. So what happens in series wound, as the name suggests, the field winding is wounded in the series. Means the armature and series field winding, they are in the series. In a series wound DC motors, the field winding is connected in series with the armature winding as shown in the figure. Means both the windings are in series. Hence it is known as RSE, which is the resistance of series, a series field winding. The current through it is ISE, means series current. This is the current through load, and this is the current from the armature. This is back EMF and this is resistance of armature. Now where you can see this kind of series wound DC motors are where large starting torque is required, like in elevators, electric tractions and cranes. In this type of applications, this kind of series wound DC motors are used. So this is, you can also say, as its advantage. The DC motors have higher starting torque than the AC motors. Hence, they are used in large starting torque area, like in elevators, in electric tractions, cranes, etc. Also, they are used in air compressor, vacuum cleaners, hair dryers, and sewing machines. The B type is shunt wound, means both the windings are connected in parallel. Shunt suggests parallel connection. Means here this field winding and this armature winding, they are in parallel, means they share two common nodes. One is here and the another one is here. Hence it is named as shunt field and its resistance is RSH. Current through armature is IA. Current through this is ISH, means shunt current. This is IL, current in load. And in a shunt wound motor, the field winding is connected in parallel to the armature as shown in the figure. Now see these application areas. First is centrifugal and reciprocating pumps, in lathe machines, in blowers and fans, in milling machines, in machine tools, and also in drilling machines. You can see this type of shunt wound DC motors. Now, the third type is compound wound DC motors. Compound wound. Compound means they have combination of both, which both series and parallel. Hence, it is named as compound wound, means it has both series and shunt field winding. So, this type of DC motors have both shunt and series field winding, and they are named or known as compound DC motors, which are further classified into cumulative compound motor and differential compound motor. So a typical compound wound DC motor looks something like this. This is a armature winding, and into a series there is also a field winding, and in the parallel there is also a field winding. Hence this is series field and this is shunt field, and combination of both of them is known as compound wound DC motors. Now in a cumulative compound wound motors, the magnetic flux produced by both the windings is in the same direction, hence it is named as cumulative. While in the differential compound wound motors, the magnetic flux produced by the series field winding is opposite to the flux produced by shunt field winding. Means the direction of flux is in the opposite. While in cumulative, the magnetic flux produced by both the windings are in the same direction. Now, let's move forward to our fourth part of this section, which is the types of DC motor, which are brushless DC motors and brushed DC motors. So, this is the brushless DC motor and this is conventional or brushed DC motors. As the name suggests, means the main difference in both of them is one has brushes in it and the another one has no brushes at all. So first is brushed DC motor. So this is how inner part of a brushed DC motor looks like. A brushed DC electric motor generates torque directly from DC power supplied to the motor by using internal commutation. Stationary magnets, which are permanent, or electromagnets, and rotating electromagnets. So in this type of DC motors, the torque is directly generated from DC power supplied to the motor. Now let's see the advantages and disadvantages. So the advantages of this kind of motors or brushed motors are they are low initial cost. Means the initial cost of them is very low. High reliability means this type of motors are highly reliable, and also they provide simple control of speed. Means the brushed DC motors have simple control of its motor speed, while its disadvantages are they are high maintenance and low lifespan. Because they are using brushes, the maintenance of this kind of DC motors is high, and also due to the frictions in brushes decreases the lifespan of the motors, hence they are in high maintenance, also have low lifespan. This is the inner mechanism of brushed DC motors and brushless DC motors. So these are the brushed DC motors inner mechanism, and this is the brushless DC motors inner mechanism. Now let's see the brushless DC motor. So in brushless DC motor there are no brushes, and its abbreviation is BLDC, brushless DC motor, also known as synchronous DC motor. Unlike brushed DC motors do not have a commutator, means they do not have brushes, also commutator. The commutator in a brushless DC motor is replaced by an electronic servo mechanism that can detect and adjust the angle of rotor. Means the function of commutator and brush unit in brushed DC motor is replaced by a electronic servo mechanism that detects the angle in the brushless DC motor. So we have seen that in brushed DC motors the combination or the unit of commutator and brushes are there to provide or to transmit electric current from stator to rotor. So they were responsible, the whole unit of commutator and brushes, they were responsible for the transmission of current. But in the brushless DC motor, this function is replaced by electronic servo mechanism, which can detect and adjust the angle of rotor. Now let's see the advantages of BLDC motors. So these are high power to weight ratio. Means this kind of motors have high power to weight ratio. They are low in maintenance. Hence they are low in maintenance because they do not have brushes. High efficiency. The BLDC motors are higher in efficiency. Also they have high speed and instantaneous control of speed and torque compared to brushed DC motors. Means these are the advantages of the BLDC motors. Now let's see the applications of BLDC motors. Now these BLDC motors are widely used. So let's see its applications. First, in industrial engineering, these motors are ideally suited for manufacturing applications because of their high power density, higher efficiency, and low maintenance. So because of these advantages, they are used in manufacturing applications. They are widely used in industries for motion control, linear actuators, servo motors, actuators, for industrial robots and extruder drive motors. They also used as pump, fan and spindle drives in adjustable or variable speed applications, as they are capable of developing high torque with good speed response. Means they are capable of developing high torque with good speed response. They are used as a fan, pump and spindle drives in adjustable or variable speed applications. So this was the industrial engineering application. Now let's see in transport. So this type of motors are found in electrical vehicles. So these BLDC motors are used in electrical vehicles, personal transports, hybrid vehicles and electric aircraft. As we have seen in the first part that these DC motors are used in the vehicles. So these BLDC motors are used in transport also. Heating and ventilation. So heating, ventilation and air conditioning, refrigeration, nowadays these motors are used because of reduction in power required to operate them. Means they require lesser power and hence they are used in heating, ventilation, air conditioning and refrigeration purpose. In cordless tools. So BLDC motors are used in cordless tools including some string trimmers, leaf blowers, saws and drill drivers. In aero modeling, BLDC motors have become popular motor choice for model aircraft including helicopters and drones. So now BLDC motors are used in helicopters and drones. Their favorable power to weight ratio and wide range of available sizes have revolutionized the market of electric powered model flights. Means their power to weight ratio means you can, and also wide range of available size means they are available in so many different size, and because of these two advantages they are used in electric powered model flights. Radio controlled cars, RC cars. These motors provide high power to RC car racers and are capable of producing more torque and have a faster peak rotational speed. Means these kind of BLDC motors are used in RC cars. So thank you so much. This was all about DC motors, their types, applications. We will see you in the next tutorial.